I'm going to use, can I talk here, please? Okay, ready? Okay, the best thing I'm going to do for this one is I'm actually going to draw a picture. You do not need to make a picture quite, quite as accurate as mine, but it's easiest to see things out here, okay? So I'm going to draw my 2 points. There's 1, 2, 3, 4, 5. And we have 1, 2, and we have -1, -2, -3. So point A is going to be here, which is sort of x and y. Point 3 is going to be here. Point X is going to be there. Point Y is going to be here. And I want to, oh my goodness, excuse me. And I want to find this distance here. Can anyone recall back from grade 10 how we would find that distance? Go ahead, Evan. Yeah, good. Okay, so the actual equation would be D is something like this. That should be your distance formula, is that right? No, that's right to me. That should be what the distance formula is. Now I want us to use the formula in the long term because when we get to the third dimension, we're still going to use the same thing. So let's just show exactly what it's saying here. What they're saying is this is 5, this is 3, so that distance is going to be 2. This is 2, that's -3, that distance is going to be 5. Okay. What am I actually doing there then? Pythagorean theorem. Pythagorean theorem is where that equation actually comes from. Okay, so I'm going to pick this point as x1, y1. This is going to be x2, y2. Okay, so this is going to go then as square root of 5 minus 3 squared plus -3 minus 2 squared, which happens to be the root of 2 squared plus 5 squared. Okay, now, what I would like guys, can I please do this, guys? This is very difficult to talk when you're talking. I know you are not going nice in the seating plan, but if people want to yak all through class, go to gym instead of take this class. Oh, I don't know why I've done it at gym. Please don't tell Mrs. Ollinger to show lunch Sunday or something like that, okay? But again, for this, it is actually Pythagorean theorem. That's all I'm trying to do, but I actually need the equation. Now, as I keep saying, we're going to the third dimension in this unit. Okay, so we'll get into a 3D distance problem too, which will have a similar equation. We'll get to that though in the next few days. Is this coming back for most people from grade 10? I hope. Don't you see it? Other than that? Okay, do you understand what's going on now though? You don't remember from grade 10? Matt? Do you understand where it's coming from? Okay. All right, the one that we don't understand is going to be elimination. The reason I even feel bad about this is because when I'm in grade 11, if you were in my class, I poo-pooed elimination. Like I would say, I never use elimination for anything. I say substitution is always better. Yeah. That's what I say. Those are actually direct quotes, okay? But in this case, substitution is not better. Why look at that one? If you think of substitution, what would you do if I wanted to solve that with substitution? 2 equations, 2 unknowns. What would you do? You'd isolate one variable, okay? Why would it be a nightmare to isolate a variable in this case? Decimals and fractions and yuck, I don't want to do it, okay? Like there'd be a decimal divided by a decimal, which is going to be an uglier decimal, okay? So I'm going to try and avoid that if I can. I'm going to use elimination. The way we do elimination is we want to remove one variable. So what I'm actually going to do is I'm going to eliminate y. The reason I'm going to eliminate y is that one is a positive, one is a negative. How can I make both of those numbers the same so I can cancel them out? Multiply by something good. And you know what something is? I'll help you. Okay. I'm going to multiply this first one by 2.8. I'm going to multiply the second one by 5.2. That's not even LCD. That's just numbers. Where did I get those numbers from? It's the opposite. Now, I'm sure there's an LCD that works better than that. But that'll work nicely. I need someone with the calculator now. Amy, you're going to be my calculator person today. Can you please do, now you have to multiply, remember, the entire row by those numbers. Can you multiply, give me the whole new equation, please. And by the way, when I say Amy, I mean everyone should be doing this, not just Amy. 10.64? 0.12. Okay. Now that looks frightening. You're saying, Mr. Seiler, this doesn't look better. In fact, it looks worse. Let me tell you, Charlena, this will be better in a minute. Charlena, can you multiply the whole second equation, whoops, by 5.2, please? Yeah? Okay.
32.76.
All right. Looking at this question, although there's hideous decimals, and we don't like decimals because we're in calculus, but they're on the board, so we'll deal with it. Why am I happy with this now? What can I do for it? I see this. Yeah, they're going to cancel, right? All we're going to do is we're going to add north-south, like top downwards. Okay, so I'm going to say 10.64x plus 11.96 should be 21. I can't do it in my head. 22.5. Is that right? I trust Michael. Is Michael right? I trust Michael. And this should be, Michael, you got this one too? 8.3. I see that's right. I see I'm right now. Am I right? Am I finally right? Okay. Remind me, you don't need your sales chapter on this example because I don't have to do it. You know what I'm talking about?
Yeah.
Okay. Final step here to solve for x is going to be what?
5.
Good. What do we get? Hopefully a nice number. Exactly. Good. That's nice. Now thinking back to grade 10 or whenever we did this last, how do you solve for y, please? Good. I'm going to use the first one. It doesn't really matter, okay? So it's going to be 3.8 bracket 1.4 minus 5.2y, sorry, plus 5.2y equals negative 0.4. Yeah, I don't want to try and do this. My head's hurt today. 3.8 times 1.4, please. 5.32, thank you. There's no rounding, that should work out exactly, I hope. Someone confirm that for me? I hope. Yes. Therefore, POI is 1.4. In this unit, we're going to be doing a ton of intersection of lines and stuff like that, okay, a lot. Okay, and perpendicular is important, normals are important, all sorts of those things. Now, I didn't mean to insult you by saying this is grade 10. This would be like the level 4 plus question in grade 10 that would make all my students cry, okay, in grade 10, okay? So it's okay for review for calculus. Are we okay on the logic of what we did there? Yes.
When we're adding those equations,
Yes.
what are we doing
One more time, sir?
We're just adding those equations.
Yeah.
They don't turn as
Yes.
like
Well, just here and here and here and here and here and here originally. The problem is you'd end up with a negative, and you'd still be a y with it on there.
Because the magnitude of them is the same.
you never just take two equations, take two statements, and then treat them like
He's asking why that.
why did you take two equations?
Okay, because well, think what we're doing back from grade 9, grade 10, and we're finding intersection lines. That's what we're doing. Okay. So what we're just doing is like we're just combining them. That's all we're doing. Two expressions are just combined. That's all we're doing. Okay, because since they're equal, you're allowed to do such a thing, right? Because they all have to be equal. These are two graphs on the same set of graph paper, so they have to be. All we're saying is you're combining them in different ways to see that they're going to add up. That's it. Okay, so algebraically you're allowed to do that. That's fine, right? I'm not breaking the rules. I know this is true given. This is given as true. This is given as true. So any combination of them should also be true. That's the fact we're using. All right, I'm going to hit pause in the video. Michael's going to sell something to you right now. Here we go. Wait, let me hit pause the video first. No, here's your sales page.